and today we're going to discuss what is domestic wastewater treatment. And before that, let us know what is a wastewater. So wastewater is a water that is used and must be treated before it is released in the body of water like river, so that it won't cause further pollution to the water sources. So wastewater comes from a variety of sources like the rainwater, there is a rainwater, water from industry, agriculture, and the domestic wastewater. In a domestic sense, wastewater is split into three categories: the black water, gray water, and the yellow water. Black water is a wastewater that comes from your toilet, kitchen sinks, and the dishwasher. Feces, urines, and toilet papers, a bit of discarded food, and plenty of cleaning liquids and chemicals are found in black water. And as a result, the water is highly contaminated and could potentially cause various diseases. Next is the gray water. Gray water, or in simple terms, gray water is a black water that does not have feces, urine, and food waste. It comes from baths, bathroom sinks, and the washing machine. While it contains chemicals and cleaning liquids, it is much more suitable for reuse because it is not pathogenic. And lastly, yellow water. Yellow water comes from urine and just pure urine. That's all. A wastewater that comes from a human household activities such as baths, laundry, dishwashing, garbage disposal, toilets, etc. is called as domestic wastewater, which usually contains relatively small contaminants, but even small pollutants can make a big impact on the environment. So here comes domestic wastewater treatment that ensures all household sewage is properly treated to make it clean, safe, and is suitable for releasing back into the environment. Possible contaminants found in household wastewater includes disease-causing bacteria, infectious viruses, household chemicals, and excess nutrients such as nitrate. Wastewater treatment can be categorized as secondary treatment and advanced wastewater treatment. So secondary treatment involves biological treatment which is called activated sludge process. The wastewater is mixed with bacteria-laden sludge and oxygen, which allow the bacteria to break down organic matter. And the water is passed into a sedimentation tank where the active sludge is collected and removed. So the primary objective of secondary treatment is to remove organic matter and total suspended solids and kill pathogens. And advanced wastewater treatment systems are those used for producing a much more higher quality than what is accomplished in the secondary treatment. The AWT facilities are designed to remove nitrogen and phosphorus through biological and chemical means.
Overview for the wastewater treatment process. So how can a toxic water becomes pure water? So here are the steps of wastewater treatment. First step is the collection of wastewater. Collecting all the wastewater from every single household in the neighborhood, and those water or wastewaters which are formed out of every single home are collected by huge collection pipes. The second one is the preliminary treatment. In preliminary wastewater treatment, it is the physical treatment and the clarification of large particles. So in that wastewater that we have carries many impurities. It carries all the solid particles, the large solid particles, and the small solid particles. It includes all the organic matter, and along with that, it also carries some chemical waste. So all of these things are present in that wastewater. This preliminary treatment is designed to only separate the large particles from that wastewater. Then it converts to the process known as primary wastewater treatment, and that process is the third step. The primary treatment is the physical treatment of smaller particles. The fourth one is the secondary wastewater treatment. After the preliminary and primary treatment, all the physical measures are there. Separation of solids from the liquids are already done. So, in secondary treatments, we mostly have liquid wastewater. They don't carry any large or small particles because those are already removed during preliminary and primary treatment. So in the secondary wastewater, we use biological agents like bacteria, fungi, or protozoa. And this biological treatment kind of causes to take out all those organic components that are present in the wastewater or the water, and they use those organic components to grow themselves. In turn, they are reducing the amount of organic compounds in the wastewater, and that is really important. So after secondary wastewater treatment is done, we initially add microorganisms in huge chambers where the liquid wastewater is present so that those organisms can do their job of eating those organic compounds present in that wastewater. And the last one is the tertiary wastewater treatment. The tertiary treatment comes after the secondary treatment, and in this tertiary wastewater treatment, this is the chemical treatment process. The chemical treatment means in this case we simply use chemical agents to purify the water. Example of these chemical agents are ozone gas or chlorine as a gaseous form or liquid form. Also, we can use sand filters. And there is a reverse osmosis. So there are many different mechanisms used to purify the water. So we generally use this chemical treatment like chlorine and ozone for treating, and generally, we use this chemical treatment to reduce the odor as well as to kill any of the present microorganisms that we use in the secondary treatment. Because we cannot put microorganisms like bacteria and fungi in our water and drink it, because if we do, we will get sick eventually. So that's another thing. So we have to get rid of them using those agents, and then finally, it comes down to sludge processing. And that was it.
And now let us know more on what is preliminary treatment. So preliminary treatment, as what I have said, is the removal of constituents or the large particles in the wastewater. And the purpose of this preliminary treatment is to protect the operation of a wastewater treatment plant by removing the large debris or the large particles in the wastewater that can clog or damage the pumps. So it is really important to remove the large particles before proceeding to the next process. Also, preliminary treatment focuses primarily on physical treatment schemes involving screening and grit removal. Screening. So screening is basically the first unit operation in treating wastewater. It removes objects such as rags, papers, plastics, and metals to prevent clogging and the damage. There are two types of screens, the coarse screens and the fine screens. So coarse screens is used to remove the large solids, rags, and debris from the wastewater, and typically have openings of 6 mm, while the fine screen is used to remove materials that may create problems in the downstream processes. Typical openings for fine screen are 1.5 to 6 mm. Another unit operation performed during preliminary treatment is the grit removal. So grit consists of sand, silt, small gravel, eggshells, and any other inert materials that has a specific gravity of 2.65. The grit removal process is also a very important part of the preliminary treatment since it removes the debris that can cause damage to the downstream equipment such as pumps, as well as preventing the clogging of the pipes. It also prevents the accumulation of inorganic, undigestible material in digesters, aeration tanks, and the solids handling processes. And there are different grit chamber designs that are in common use for grit removal. This includes manually and mechanically cleaned grit chambers, the aerated grit chambers, and the vortex grit chamber. In secondary treatment, it removes soluble organic material that escapes the primary treatment or the preliminary treatment. It also removes more of the suspended solids than the primary treatment does. And also, the removal is usually accomplished by biological process in which microbes or microorganisms consume the organic impurities such as food, converting them into carbon dioxide, water, and energy for their own growth and reproduction. There are three basic biological treatment methods: the trickling filter, activated sludge process, and the oxidation ponds. So a trickling filter consists of a bed of coarse materials such as stones, slots, or plastic materials over which wastewater is applied. The settled sewage is sprayed continuously over the top of the stones and trickles to the bottom, where it is collected for further treatment. And the activated sludge treatment systems consist of an aeration tank followed by a secondary clarifier. And the settled sewage mixed with fresh sludge that is recirculated from the secondary clarifier is introduced into the aeration tank. And the last process or the last method is the oxidation ponds. So oxidation ponds, also called lagoons or stabilization ponds, are large, shallow ponds designed to treat wastewater through the interaction of bacteria, sunlight, and algae. So the algae grow using energy from the sun and carbon dioxide and inorganic compounds released by bacteria in the water. And during the process of photosynthesis, the algae release oxygen needed by the aerobic bacteria. In recent years, oxidation pond has been widely used as a collective term for all types of ponds. Originally, an oxidation pond was a pond that received partially treated wastewater, whereas a pond that received raw wastewater was known as a sewage lagoon. So secondary clarification also is a vital component of most of the biological wastewater treatment systems. The fundamental objective of a secondary clarifiers is to separate the biological flux from the treated liquid waste stream. The secondary clarifiers are most often discussed in the conjunction with suspended growth biological wastewater treatment systems. Next is the disinfection of wastewater. So the process of killing pathogenic bacteria and making wastewater safe to the public use is called the disinfection. The commonly used disinfectant element is the chlorine, and the process of applying chlorine in a small quantity of water is called chlorination. The addition of chlorine gas or some other forms of chlorine is the process most commonly used for wastewater disinfection in the United States. And the chlorine is injected into the wastewater by automated feeding systems, and the wastewater then flows into the basins where it is held for about 15 minutes to allow the chlorine to react with the pathogens. So wastewater must be disinfected in situations where humans may come in contact with it. So disinfection can be accomplished by one of these four methods. These four methods are the chemical agents, physical agents, the mechanical means, and the radiation. The main chemical agents used includes chlorine and its various forms such as chlorine dioxide, chloramines, and sodium hypochlorite and calcium hypochlorite, along with the ozone. And the physical agents that are used includes heat, light, and the sound waves. So heating wastewater to boiling point is not practical. However, the ultraviolet radiation spectrum of sunlight is effective in inactivating the pathogens. While mechanical means are those methods that removes potential pathogens from the wastewater as it passes through the screens, grit chamber, and the settling basins. The last method is the radiation. So the chemical addition with chlorine or ozones and UV treatment are the primary means of disinfecting wastewater. Both ozonation and UV radiation offer the advantage of not having to remove chlorine if the effluent is discharged to the surface waters. So it is much easier to use the UV radiation or the UV treatment rather than chlorine because the chlorine has many side chemicals that you have to remove after it disinfects the water. And the last topic we have for domestic wastewater treatment is the sludge treatment process. So the quality of the sludge varies according to the composition of the starting residual water. The sludge generated during wastewater treatment process can be classified into 3 types depending on the criteria used. So the first criteria is according to the origin of the effluent to be treated, if it is urban sludge or the industrial sludge. The second criteria is according to the wastewater treatment stage, the primary sludge, the secondary sludge which is biological, the mixed sludge, and the tertiary sludge. And the third one is according to the sludge line treatment, if it is thickening, the thick sludge, stabilization, stabilized sludge or digested, and the dehydration, the dehydrated sludge. So for thickening, the process involved in this stage lead to a reduction in the volume of the sludge to be treated by eliminating water and increasing the concentration of the solids. The main objective is to increase the efficiency and financial optimization of the subsequent processes. The next one is the stabilization. The stabilization process are divided into 3: the biological stabilization, chemical stabilization, and the conditioning. So in biological stabilization, this is a biological process to oxidize organic material by microbiological action and oxygen supplied in open digesters. This reduces the final mass of the sludge to adapt it for use in the later processes. And the chemical stabilization is the alternative to biological stabilization, whose purpose is to reduce or minimize pathogens and substantially reduce odor producing microorganisms. In conditioning, the gelatinous sludge can make drying operations difficult, and in these cases, preconditioning is carried out to improve the characteristics of the sludge before going into the dehydration. And for the dehydration is the physical operation used to reduce the moisture content of the sludge and its volume. Its main objectives are to increase the dry matter content of the soil by 3 to 40%, reduce transport costs due to volume reduction, improve the handling and transportation of the sludge, avoid odors, and increase the calorific value by decreasing the humidity. And that was all for the domestic wastewater treatment.